kind of driving into Yukon brought back memories. Driving by good old Wellington Pizza and all that kind of stuff. I walked into Jaime Arjona and like, wow. I remember watching movies and hanging out there. That is back my pagan days, I have to admit. I was not a well-behaved college student. You know the radio tower there, Yukon, I climbed that a few times. And, you know, I was not only high on the tower, but it's not the glory days, not really, not for a Christian anyway. There's people back there. We should, kind of move forward there so I can kind of see you and stuff like that. You don't have to, but I'm not going to be doing a lot of Bible stuff. We're going to talk about science and Christianity a bit. And then the second class, to be honest with you, is the one that I'm more excited about because I get to kind of get into the Bible and Jesus. I always like to talk about Jesus. In fact, Danny was asking me what I'd like to speak on tomorrow morning. I want to talk about Jesus. I mean, that's kind of what Christianity is about. It's about Jesus.
Amen.
So I'll just share a little bit then, a shorter lesson perhaps, about science and Christianity. When I went off to Yukon, I was an atheist. At least I said I was anyway. I'd been like, in church and the church youth group and all that, but I didn't believe in God. And so I remember coming to Yukon and taking my first philosophy course, and Nietzsche said God is dead, and I was pretty, that's for sure, Of course, Nietzsche's dead, and God's still kicking. But I came to believe in God, at least initially, from studying science. And there's this common idea out there that all right, for people that aren't very smart, and don't have a whole lot of education, and kind of into easily duped, they could believe in the Bible. But obviously, anybody with a whole lot of education, and obviously they would see the foolishness of that, wouldn't believe in God. Especially scientists. I mean, obviously anybody who studied science wouldn't believe in God. And I want to respond by that to say, I think that's utter nonsense.
That's right.
It doesn't make sense at all. And I'd say, and I'm going to show you why I'm not just talking, just a bunch of rhetoric.
Come on,
I'd say the person with the least conceivable reason to not believe in God would have to be the scientist. Because it's so obvious. So what I'm going to do is I'm just going to share a few thoughts based from that idea. Can this thing be turned around so I can see what you all are seeing?
Yeah.
Fun.
All right, good. I want to invite you to our conference. We've had a few conferences. This one's going to be on, wow, this is an unusual topic, Christianity and the paranormal.
Wow.
I don't know how many lessons you've had on that, all right? That's going to be on the Queen Mary, the most haunted place in America, supposedly. We'll even have like a professional ghostologist or whatever.
Wow. Very good, brother.
So anyway, so we're going to consider two views. One would be represented by Thomas Huxley, good friend of Charles Darwin. He said, "We are as much the product of blind forces as is the falling of a stone to the earth, the ebb and flow of the tides. We just happen. Man was made flesh by a series of singularly beneficial accidents." That's the atheist view. It's all we consider. No purpose, no design. Just this molecule bumped into that molecule, and then next thing you know, there's living things, and just random stuff, and then here we are. All right, and that's supposed to be the view that smart people would go for. Right. All right, and I want to show that, at least from my perspective, that doesn't make sense. An alternative view would be the idea of design. William Paley produced a watchmaker argument. It's a classic one. And just tried to explain, what's the most reasonable picture. Like I said last night, we can't prove God exists like a mathematical equation. You have to simply ask, well, what's the most reasonable inference from what we know? All right, so Paley said, imagine you're walking down the street, you see a pocket watch, you think, all right, well, how did that get there? Oh, I don't know, maybe just by accident. Maybe some rocks, maybe they happen to have the right metals in there. People stepped on it, it rained. Kind of cars went over. Next, pocket watch. Now, I think you'd have to be irrational to reach that conclusion. But think about this. What about life? Because life exists. Apparently, some people might deny life exists, but I think it exists. And well, which is more designed? The simplest life or a pocket watch? Which has more moving parts? Which has more intricacy? Intricacy, yeah. Moving parts. I mean, the simplest conceivable living thing is so much vastly more complex than a simple pocket watch. I think a better analogy would be this. Imagine this, you had a junkyard full of metal and plastic and wood and dirt, and a hurricane comes in, and there swirls it all up, and at the end, out pops this 747. I mean, who would believe that? So I'll just share a few examples. I'm a chemistry and physics professor, so, you know, I'm just going to use stuff that would come up in the lectures that I would do. Right. And I enjoy teaching these things. My students figure out pretty quickly that I'm some sort of a believer. I'm sort of like the Christian professor on campus. One of my good friends there, he's an atheist gay biology professor. So when he has his religious students ask him questions, he says, go talk to Dr. Rich. So anyway, for example, water. Hopefully you didn't need the water. Hopefully the HOH was good enough for you. That's an attempt at humor, by the way. This is science humor, so bear with me. Okay. But you can teach an entire one semester course just to explain all the properties that water has that no other substance has. Every single one of those properties. If water didn't have that property, there'd be no life.
Yep. Wow.
All right, so, you know, I would argue this is clear evidence for design. A number of things. For example, water's bent, about a 105-degree angle. Generally, if you connected three things, 1, 2, 3, you'd think a straight line. If water was linear, it would boil at around minus 160 degrees centigrade. Obviously, there'd be no life. You know, we become vaporized pretty quickly. And the thing is, in order for life to exist, it has to have a solvent, a liquid, and to move things around, obviously. And that solvent would have to have properties to dissolve a wide variety of substances. And it turns out, in order for life to exist, you need something that's liquid somewhere between, about minus 20 and centigrade and 80 centigrade, roughly. Because below that temperature, chemical reactions simply aren't quick enough to support anything that could remotely be considered alive. And above about 80 degrees, these molecules, these delicate molecules, fall apart. Of course, water's liquid across almost the whole range, but luckily, as we'll see, it's frozen, at least for a little bit of that range, for reasons that we'll see. But anyway, water is literally the only liquid, the only one that's liquid in that temperature which can dissolve ions. Luckily for us, because without ions, conducting ions, then, the whole, nervous impulse going to another place in the body wouldn't work, wouldn't have a nervous system. Water dissolves a wide range of molecules as well, but not all molecules, luckily. Otherwise, we'd be a puddle, which would be problematic. Another thing about water, by far more than any other substance, water absorbs heat. And it has a high specific heat, far higher than any other substance. And if water didn't have this property, the same one that has the right boiling point and has the right solvent properties, if water didn't have this property of absorbing heat, then the temperature of the earth would go up and down by 200 or 300 degrees centigrade in any given year. Obviously, life wouldn't exist. Many other properties. Another property water has, I assume you're aware that ice floats on water. Yes, that's familiar to you? Yeah. Well, all right, that seems obvious and normal, but actually, there are millions and millions of compounds. Guess how many have the solid floating on the liquid? One out of millions and millions of compounds. Just so happens the substance that is the solvent for life, that has the right specific heat, the right boiling point, is also the substance that has the solid floating on the liquid. Coincidence? Maybe, I suppose. But if ice didn't float on water, then in the winter, of course, the lakes would freeze right down to the bottom. Right. All right, and then during ice ages, the oceans would freeze right down to the bottom. Life would disappear, certainly advanced forms of life. All right? And another strange thing about water, generally, as you heat something up, their density goes down. In fact, for all substances in the universe, when you heat up, their density goes down. Guess how many exceptions there are? One, water again. Because below 4 degrees centigrade, for some strange reason, the density of water actually goes up. Yeah. Why? Well, again, it goes back to the whole water-ice thing, because ice is a bad conductor of heat, luckily for us. All right? And what happens is you have the cold ice, the cold water, and then the slightly warmer water, which is heavier below that, and it's like a natural blanket. And we can talk about the viscosity of water. There's so many properties water has, but at some point, the whole, just an accidental thing starts to not work very well. Right? Some of you are maybe getting cold sweats here. When I teach intro chem, I tell them, yeah, Mendeleev invented the chart, but actually, secretly, what I'm thinking, that's not true. Guess who invented that chart? It's easy, God. And God's fingerprints are all over the place. And the thing is, as we learn more in science, this truth becomes much more obvious over time. All right, just several elements have properties. And again, what's sort of cool about it is the only element that has that property is that one element, none other does. And if that element didn't have that property, we wouldn't be here. All right? So it seems to point towards the idea of somebody very intelligent here kind of selecting these properties and making this universe where those properties exist. One example is carbon. Carbon has properties, and I love teaching organic chemistry because the first two lectures, I spend the first two lectures teaching about the properties that carbon has that make it unique. And of course, if carbon didn't have those properties, then we wouldn't be here talking about it, that's for sure. A number of them. First of all, carbon forms 4 bonds. Okay, why is that significant? Well, the reason it's significant is because if atoms don't have 4 bonds, then the molecules are not three-dimensional. And if you don't have three-dimensional molecules, then obviously you don't have a three-dimensional living thing either. Actually, it's not the only element that forms 4 bonds. For example, silicon also does. The problem with silicon is that if you try to form a molecule with more than one silicon atom bonded together, it explodes. Not a very good candidate.
Okay.
Anyway, carbon happens to also be the only element that forms large molecules. The only one. Now, obviously, we need large molecules to have a living thing. And again, that's a whole 2-hour lecture. I'm not going to go into all the details. Kind of give you a feeling for it. Okay, another element that has important unique properties is iron. Because iron, as you're probably aware, is the only element that forms a strong magnetic field. Which is absolutely essential, because what else would you do with your children's homework assignments? On the refrigerator, I don't know what you do about that. No, that's not why it's essential. Okay, it goes back to the sun. Now, again, in order for life to exist, we need a source of energy, but most sources of energy are at a very high temperature. I wouldn't want to be there. And of course, hydrogen is the only element that has the property of fusing to create fantastic amounts of energy. Again, luckily for us. But the thing is, although almost all the energy from the sun is visible light, again, luckily for us, because visible light is the only kind of light that has enough energy to induce important chemical reactions without blowing the molecules apart. Almost all the energy from the sun just happens to be visible light. However, there's a couple